Okay. Good morning, everyone. Thank you for joining me today. So, with continuation to the first three recorded sessions on Spark Deep Dive, Spark Transformations, Spark Transformation continuation, now I would like to go into next phase of paid RDD operations and paid RDD transformations. In that, we have a concept called subtract by key. Subtract by key is very simple. It is just returning a key value pairs containing keys that are not found in another RDD. One important logic which you must be well aware here is, are you subtracting first RDD with second RDD, or are you subtracting second RDD with first RDD? If you are subtracting first with second, okay, it will check for the values what are not present in second from first. If you are subtracting second from 1, it will do vice versa. That is very important. Here we are going to start with an example. Cat, A and spoon. We have two RDDs. One is WIR RDD and other is song RDD. When you subtract second one with first one, it is checking what is that second one is not same as first one. Okay, let me quickly show you that one also. What do they have here? I have cat A comma 0, A comma 1. Cat comma 0. This is first data set, and second data set will be A comma 0. Third one will be spoon comma 2. Okay, this is first data set. And what second one? I have RDD song, or I'll do song RDD. PARALLELIZE. The only reason why I don't copy paste is I want you guys to be familiar with as much as possible. You know why I'm using close circle brackets first, and then square brackets inside, and then representing a data set with that one, right? So cat 7, cradle 9, spoon 4. Cat 7, cradle 9, cradle 9. Hold on. There's spelling mistake here. Syntax error. Okay. Cat 7, cradle 9, and then spoon 4. Okay, that's it. Now we have done it perfectly. You have two RDDs, you have parallelized two RDDs. So now try to understand something. The subtract by key will return key value pairs containing keys not found in other RDD. Means it is not verifying the values, it is only concerned about keys. Okay, you have cat here, you have cat here, you have A here, you have cradle here, you have spoon here, you have spoon here. So the only thing you need to understand is it is one more thing, it is case insensitive. Let me not confuse it. I will do small case everywhere. A is fine. Spoon. Okay. And now I have song already. What we are going to do is we are going to subtract by key. Subtract by key, we are using second one, subtract by key with first one and then collect. Okay. So song RDD dot, what is the syntax name? Subtract by key. Subtract by key of first one, which is zip WIR RDD. Okay, dot collect. It gave Cradle and cat. Okay, you should only get Cradle, but you got cat and 7. I'll tell you the reason why. Because you have cat as uppercase C. Okay, don't do that. Now let's put this way. Song RDD is done. Zip is done. Now I'll subtract this one. You got Cradle only. So you understood the difference. Comparing the keys and verifying which key is not present in the subtracted one. If you do one first RDD with second RDD, it will go and verify in the first one. Or if you do second with first one, it will get second one. Okay, that is the important part of it. Let me quickly go to home and do a slideshow from there, so the screen will be big for everyone. So many things you have covered. I'm happy. So this is done. Okay, so if you see here, this is RDD, song RDD subtracted by zip VR RDD. We'll do one thing different. Okay, so here what we'll do is zip VIR RDD subtracted by song RDD. Spelling mistake. Let me quickly check what is that. Zip WIR RDD. Spelling mistake. 1 second. I'm sorry for that. Is it R small case or R uppercase? WIR RDD. You got A comma 0. The reason why you got A comma 0 is, carefully observe, this is your A comma 0 with zip RDD. This is your this one. So you have cat, you have spoon. You don't have A in second one when compared to first one. That is how a big difference it makes. This is the way you can use subtract by key. But one thing you need to be aware is which one you are subtracting with which one. Okay. The first thing is subtract by key is only evaluating matches in the first RDD. The one proceeds the function as compared to second one. Every time it only compares the first RDD with the second RDD. It does not return all keys in either RDD that are unique to that RDD. If you wanted to get a list of unique RDDs for both unique RDDs in unique RDD keys or unique keys for both RDDs, you should be using subtract by key. You would need to run the operation twice, once as shown and then again swapping out two RDD values in the last code. Okay, he's just shown you how he has done for 1 and 2 and 2 and 1. If needed, you could store these outputs into two other RDDs, then use another function to combine them into a single list as desired, which we will be doing in later stages. Don't worry about that now. Okay, this is the way you can use subtract by key. Now, paired RDD joins. This is very important. This one, the whole agenda is how Spark is providing the functionality of joining different RDDs. You have RDD1, you have RDD2. When you join, are you using inner join, outer join, left outer join? And the way the joins work, you can have the common result first and then all of the values next. We will be using joins everywhere in Spark. Joins are the basic important functionality or functions transformations we will be using. And here, if you see, you have two RDDs And in this RDD, when you do a left outer join, you need to understand how the functions will give you the results. On top of it, are you joining first one with second one, or second and first one is the thing that matters. Now let us go and simply check how we are performing a left outer join. Okay, what I'll do is I'll just follow the same thing. RDD song RDD dot left outer join. I'm just checking the syntax. Left outer join. See, you got spoon 4,2, you have cradle 9,9, you got cat 7,0. Okay, let me quickly check you now, show you now. You have spoon. 1 minute, I'm just showing you that one. That is the reason I'm. See, your spoon value is 4,2. Here it has joined everything. Results for your spoon, okay, is 4,2. Results for your cradle 9, none, because it's 0. Sorry, cradle is 9 and here you don't have anything. Okay, that's the reason it has not given anything. If you see cat 7, 0, it has left this one because it has joined, it has used left join to show you, to give you the results how that will work. When it has joined, it made a common key and list of values. Spoon is your key, 4, 2 is your value. Cat is your key, 7, 0 is a value. So you have one key and list of values now. Okay, that is the importance of your what I can say, uh, outer joins, inner joins, and joining. So joining two key value pairs gives you one common key and list of values. Okay, next one, let's quickly answer three questions. An RDD that contains elements made up of key value pairs is sometimes referred to as dash. An RDD contains elements made up of key value pairs is sometimes referred to as dash. Quick. Answers please. An RDD that contains elements made up of key value pairs is sometimes referred to as dash. It's paired RDD. Second one, name the two functions that can be used to create a paired RDD. Why everybody is silent today? That's fine. Let's go to answers if you're feeling bored. Now I'll go to answers. Now, an RDD contains elements that made up of key values called as paired RDD. Name two functions that can be defined to use create a paired RDD. You can use map, you can use key by, zip with index, and zip. A key that have a value is actually list of many values. That's true. Since sort by key only sort by key and there is no equivalent function to sort by values, how could you be getting your pair RDD sorted alphabetically by value? You just sort your you just change, you swap your key to value to key, and then apply the transformation top of it. See, if you see here, first use map to reorder key value pair so that key is on now the value, then use sort by key to sort. Finally, use map again to swap the keys and values back to the original positions. We discuss this very clearly. You determine either reduce by key or group by key could be used in your program to get the same results. Which one should you choose? Reduce by key, because reduce by key is more efficient in big data sets. How can you use subtract by key to determine all of the unique keys across two RDDs? Run it twice, switching the order of RDDs each time. Okay. If you want to get the unique result, you have to do subtract by key 2 times, because subtract by key first time gives you one set in your RDD which is unique, and that one may have different value but same key. You want completely isolated one. That's the reason why you have to subtract once again. Okay, that's what it is. Now, summary, just quick summary what we have discussed with the paired RDDs. Paired RDDs contain elements made up of key value pairs. We have discussed very clearly every guys, why people are, why today answers were not so spontaneous? That's fine. Pair RDD contains elements made of key value pairs, which we have discussed very clearly. The common functions used to create pair RDDs is map, key by, zip with index, and zip. Once again, common functions used to create pair RDDs including map, key by, zip with index, and zip. Common functions used with pair RDDs includes map values, keys, values, sort by key, lookup, count by key, correct as map, reduce by key, group by key, flat map values, subtract by key, and various join types. Now, this in every function I have shown you here. Do you have any questions? Are you not clear with any of the function? Okay, if you are not clear, let me know. If you don't understand this, the next topic which we are going to talk is Spark streaming, which is real-time data streaming from Spark to HDFS, and how Spark process your real-time data. If you don't understand these functions, the way how Spark streaming works is of no use for you. So I kindly request everyone of you clearly visualize what is map, what is key by, what is zip with index, what is zip, what is map values, keys, values, sort by key, and everything. If you're not clear, we can talk offline, but make sure you got the things clear. Okay, I hope you're all happy and moving forward. Yeah, perfect, clear. Okay, I'm moving forward with the next important and 100% usage process in every company, which is Spark streaming. Now let's understand what is Spark streaming. There has been no video on YouTube on Spark streaming. Everybody has started I'm not finding fault with them because everybody has got their own way of uh, prioritizing the topics. I am following the Hortonworks knowledge base process, which will be a standard in the university level to understand the topics and work on them. That is a point which inspired me to make slides in such a way. Okay, so Spark streaming. Spark streaming is nothing but it is a tool that helps developer to utilize the Spark platform to ingest and process streaming data. Streaming data means real-time data. Real-time data means the data that is coming right now. The data means the Google trend happening right now. What is people talking about a person? What is people talking about Donald Trump? What is people talking about Hillary Clinton? What is people talking about the recent chores created in US? What are the people talking about Brexit at the moment? That Google Trends, that topics, and that streams, Facebook, Twitter, real-time logs, Windows logs, logs comparison, Telnet, Netcat, all these things are considered as streaming data. Very simple. Streaming is only one of the important tool a child of Spark used for your Spark streaming. Spark streaming is composed of a receiver which collects the streaming data in small amounts called micro batches. All the sentences I have underlined makes the whole value to each slide. That's the only reason I have underlined them. So I want you to please kindly focus on that one. Spark streaming is simply composed of a receiver which collects streaming data in small amounts called micro batches. This is clear. And these micro batches are available for processing via specialized RDDs called dstream. Now, your RDDs, your paid RDDs, your data sets are completely different to your real-time streaming dstreams. Dstreams are nothing but the micro batches data that is received by the collector from the sources. Now, the way your micro batches turned into data sets is a different thing, which I'll show you next slide. Don't worry about that. Now, In this slide, what all you need to understand is Spark Streaming, one of the extension of the Spark tool, which helps developer to use for the Spark for the real-time streaming. How it works? It is working with a process called, it has a collector. It collects the data from source through a micro batches. This micro batches data is again turned into an RDD process called dstreams. These streams can then be manipulated and further processed via Spark Streaming API, which is extension to Spark Core, to produce various output types. Now, how many of you have gone through my Kafka video? Kafka Spark Streaming video, how many of you gone through it? There is a reason why I have asked you to go through it. Now, I am going to show you the reason. How many of you have gone through? Guys, come on, don't waste my time, be fast. How many of you have gone through my Kafka Spark Streaming? Funny, not me. Okay, and then I haven't, not yet, not yet, not yet, not me, not yet. So nobody have gone through it. No problem, no problem. The reason why I am telling you repeatedly is I'm telling you openly, honestly, Spark more than in-memory processing. 80% of companies are using Spark for streaming only. If you don't understand the real-time Spark streaming, there's no point in you representing or trying to sell yourself in the market as working on Spark. Spark streaming is very, very, very important. Every client, whoever it may concern, when you say Spark, for them it is Spark streaming. For them it is Spark in-memory processing. Spark replacing MapReduce is one part of it. Using Spark streaming is one other important thing which gave wide exposure to Spark. That is the reason why I always say real-time streaming is very important. It can be Facebook, it can be Twitter, it can be your application feeding data continuously, it can be your external applications, it can be internal applications, it can be application development trying to get the feeding data from your partner. So that is where you have to start thinking. Once I finish this one, I'll give you one ideal example how the data come from website, how it's processed there. Okay, let me first finish the slides and I'll come back to that one. Okay, now these streams are collection of one or more specified RDDs divided into discrete chunks based on time interval. When you mean on time interval, all my data sets, all my RDDs cannot be pushed into one D stream. Based on the timestamp they receive, each of your RDDs will be collected in one bunch. Okay, and it is also called discrete chunks. Discrete chunks mean it cannot be a same set of chunks, it cannot be same size of chunks, it depends upon the timestamp. Okay, now when streaming source communicates with Spark streaming, what is your streaming source? It can be web, it can be Netcat, it can be Facebook, it can be Twitter, it can be a third-party application sending logs continuously, it can be third-party application collecting the data from customer and feeding you directly. Okay, now this streaming source communicates with Spark streaming. While communicating it, the receiver caches the information for a specified time period. For example, if your data is coming every 1 minute, if your data is coming every 30 seconds, 30 seconds of data will be cached 30.5 seconds and it will be processed in 31 seconds. That is called real time and near real time. Near real time means seconds gap, just seconds, not even a minute. You have to be very aware of it. The receiver caching the information for a specified time period is the important part that constitutes the whole real-time streaming. Now, Once after which this point data is converted into D stream and available for further processing. Further processing means your data reached HDFS now. Perfect. Once the data reaches HDFS, you use your Spark functions on top of it, joins, keyway values, reduce by key, group by key, aggregate by key, map values, platform values, blah, 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 whatever it is. Okay. Processing the data will be same what we discussed the transformations, but the way how your data is coming in, what are you doing for your data to coming in, how your data is received by DStream, how this DStream is broken into chunks, this is all very important. Now each discrete time period, okay, if you see my example, I have pictured very clearly every 5 seconds. This 5 seconds is a separate DStream. Okay, if you mention in your configurations, import Apache conf streaming, batch interval 5 minutes. Every batch that comes in 5 minutes will be one D stream, and that's D stream. When it is converted, when before converting that into chunks of D streams, this one will be going into a separate D stream. That separate D stream will be nothing like the Spark partitions. Fairly simple, straightforward. Any questions? Let me know. Now, we talked about D streams, we talked about RDDs. What is the big difference between D streams and RDDs? D streams have some differences compared to traditional RDDs. The first and perhaps the most consequential difference is D streams contains data physically and exist in memory at the moment of creation. But traditional RDDs don't actually contain in-memory data until an action is performed. Till an action is performed, everything is in memory. Once the action is performed, the data or results, transformed results will be written to disk or written to your REPL. Okay, that is the first difference. These streams contain physical data, exist in memory from the moment they are created. The second big difference is these streams only exist in memory until the next batch of data is ready to be processed. Two big differences. At the moment of creation, it contains data physically and exists in memory. When your D streams is when your RDDs are turned into D streams, and until the next batch is processed or until next batch is ready to be processed, till that point it exists in memory. Okay. Now, third point difference is while you perform transformations on both RDDs and D streams, RDDs create results by actions, whereas D streams create results. That's the only three big differences. Once again, you have to understand this, because if you don't understand this, you tend to confuse when you start writing a transformation on the streaming data. Okay, so the first thing is the RDDs are in memory until and unless an action is performed. It is not physical, whereas in streaming RDD or in these streams, it is physical and exists in memory from the moment of creation. And once your second batch of data is ready for processing, okay, these streams will exist in memory. And the third one is your physical RDDs will turn into collections or actions, whereas your D streams will be using outputs. Clear everyone? That's how it works. Now important point, D stream replication. D streams are fault tolerant, meaning they are written to minimum 2 executors at the moment of creation. The loss of single executor will not result in the loss of D stream. This is the reason why I told you the very important concept called Kafka, Kafka streaming, Kafka topic, Kafka partitions, and Kafka ISRs. When you create a topic in Kafka, the data will be collected in terms with reference to the topic. It creates a partition. It replicates the blocks. It creates the ISRs. If you remember, people who attended the session on Friday at Westgate, I have clearly shown how you create a Kafka topic, how your Kafka topic creates a partitions, how the partitions will be replicated across the data nodes, and how it communicates with Zookeeper. Here, your Kafka is streaming data into your HDFS. Kafka is your source, streaming source. Spark is your collector or a consumer. Now, once data has reached your D batches or your D streams, chunks will be replicated into 3 based on each D stream. These D streams will start processing the data based on the business logic or the way you write your Spark code. Okay, that is where it is. So you are aware about D stream replication as well. Fair enough. Now, receivers availability. What are the important things you must be well aware about receiver? In my case, HDFS is my receiver. Okay. Now, by default, receivers are highly available. If the executor running the receiver goes down, the receiver will immediately restart another executor, because this is the way it is. The way you have Spark partitions, the way you have Spark drivers taking your Spark request from your REPL to the cluster, the same concept is applicable here, where you have a receiver and the receiver will be taken, your Spark D streams will be taken to receiver by your executors, and if one executor running the receiver goes down, you still have another executor taking the responsibility of taking that receiver there. Okay, now Spark streaming is performing micro batching rather than true bit by bit streaming. Bit by bit streaming is performance of problem, and micro batching is fairly more easy and simple. Yes, Funny, go ahead.
Amar, in the first slide, you said receiver is a different thing, right? Here.
Yeah.
It's not HDFS.
I'm just telling you an example. I'm just telling you an example here. That's it. It can be HDFS. It cannot be HDFS. It can be Netcat. It can be just your IP logger. Anything. It can be anything.
Okay.
I'm just telling an example. If it is HDFS, how it works. If it's not HDFS, how it works.
Okay.
Any confusions here in this slide? Funny.
No, it's fine. This one is fine.
Yeah. Here I'm just trying to explain with an example. That's it. It may be HDFS. It may not be. You know, sometimes there are people who use Spark streaming for your what we call an external Apache Kinesis project. They use something very similar, but HDFS is not your what we call your receiver. Okay. Here in this diagram, if you carefully observe, our only thing is your streaming data, how it is being received into HDFS, and where your D streams comes into picture, and how Spark core is processing your data. Spark core is the transformation level. Okay. Spark streaming is the pre-layer of your Spark core. Okay. Guys, one more thing. Where is your Spark transforming the data? Spark is working on your HDFS. Correct? Your Spark streaming is a pre-layer of your Spark core. For your Spark core to transform data, it needs data to be collected for its in-memory processing. It needs data in the form of an RDD for its transformation. Now, where is it getting data from? Ideally in Hadoop, it is HDFS. It is also an open source which can be used in other environments. But here we are talking HDFS will be our what we call will be our area where your data will be landed. Once the data is landed, your Spark will start processing the streaming data in a micro batch processing rather than bit by bit streaming. That is what I wanted to highlight here. Okay. These receivers are nothing but the receivers what we're going to talk now. Now, collecting and processing data in batches can be more efficient in terms of resource utilization. I have just told you that. But it becomes very cost of latency and risks small amount of lost data. yes, there is chance of losing your chunks of data, but you have to do it very carefully. Spark streaming can be configured to process batch size as small as 1 second, which takes approximately 1 second to process, for 2-second delay from the moment data is received until a response can be generated. Very important thing. If guys focus, everyone please understand this one. Understand this one. If somebody asks you, can you please tell me how you implemented Spark streaming? Tell them straight away. We have configured Spark streaming which process the batches and bit by bit micro batches as small as 1 second, because once the data has reached, okay, it has 2 seconds delay from the moment data is received, because 1 second your feeding your streaming source takes 1 second to put your data into your HDFS and other 1 second to process your streaming. Okay, tell them that one. This you have to understand that way. Now, this has a small risk of data loss which can be mitigated by use of reliable receivers. This reliable receivers is one big ocean where developers can pinch in and make best use of Spark performance enhancements. Now, these reliable receivers are available in Scala and Java API only. They are not available in Spark. They are not available in Python. Okay. Once again, this slide, a quick recap. Receivers, you have an executor that will take your request to your Spark. Okay. This receivers, for any reason, if the executor running receiver is going down, that can be carried forward and taken by other executor. Fairly simple. Spark streaming is working on micro batches rather than bit by bit streaming. This is because it will be very faster. However, you have a performance issues. You need to do a best configuration to make sure it works well. On top of it, when your batch Spark streaming is configured to process the batch sizes as small as 1 second, it takes other 2 seconds, or it has a 2 seconds delay from the moment data is received. Okay, now here you have to be using reliable receivers because there is a small risk of data loss. How we use reliable resource receivers depends upon your talent, your exposure, your wider knowledge on the development area, and how you read the blogs, how you understand how different companies have implemented the different receivers and all this stuff. You need to understand the reliable receivers are not available in Python. They are only available in Java and API, Java and Scala APIs. Okay, that's what it is. Now, I'm going to talk more about receiver reliability. This receiver reliability is telling by default receivers are unreliable. This means there is no acknowledgement between receiver and source. What is your source? Your source can be your Kafka. Your source can be Flume. Your source can be your Facebook. Your source can be your Twitter. When your source is sending some data to your destination or source to receiver, source has to say, boss, I have sent you one batch of one micro batch of D streams. Can you please confirm if you have received it? And also your receiver, yes boss, we have sent at this second, I have received at this second. Now we have a time interval of 2 seconds gap. Okay, now we both are in heartbeated. Let's go further. This kind of acknowledgement is not there in the unreliable receivers. No record of whether data has been successfully written. No ability to ask for the retransmission of missed data. If you remember our Kafka discussions on Saturday, I told you there will be an acknowledgement on each and every Kafka topic you create. If your Kafka topic has a problem, your Kafka metadata will be deleted, but your HDFS blocks that is written through Kafka will not be deleted. In that case, you just delete the topic and recreate the topic. While you recreate the topic, you tell go and create this many partitions, go and create this many replication factor for this particular topic. Once you initiate that command, it will start resyncing it. Once it resyncs, it initiates a new IRS. Okay. In this case, the reason why I have told you that is, if your D streams and Spark processing is not able to identify if it has written 3 blocks successfully, If it has failed to do so, how can it retransmit the missing data is also important thing. Possibility of data loss if receiver is lost. Now, to implement reliable resources, custom receiver must be created. This custom receivers implements the handshake request that acknowledge the data that has been received and processed. Fair enough. Assuming the data source is so intelligent, it will wait to discard the data on other side until this acknowledgement has received. That is the smartness and greatness of the reliable receivers. These reliable receivers are custom-made receivers in such a way when data is coming from source to destination or from your source to receiver, it will wait. It is smart enough that it will discard the data on other side only after getting an acknowledgement that it has received, which also means it can retransmit it if any data is lost. Custom receivers are available in Scala and Java Spark streaming APIs only. They are not available in Python. Okay. Now, streaming data source example. Spark streaming can receive data from multiple sources, both basic and advanced. Basic will be HDFS and ingesting new files that create a streaming data. It is TCP socket, Netcat example like that. And advanced sources will include Kafka, Amazon Kinesis. Amazon Kinesis is a project which I have just explained you. Amazon Apache Flume and MQTT. Note, additional data sources are available via Scala and Java APIs only. I'm repeating this because that's very important thing you have to understand. Now, basic streaming. We'll examine the basic streaming and creating the data stream using Spark streaming. Guys, streaming context. How many of you remember the importance of Spark context when we started learning Spark? I told you very clearly, Spark context is a core of Spark like that. Your Spark streaming context extends the Spark core architecture functionality by layering a streaming context on top of Spark context. Topic done. Now, this Spark context in association with streaming context acts as the entry point of streaming applications. It is responsible for setting up receivers and enables real-time transformations through D-streams. The way your Spark context can work with Java, can work with Scala, can work with Python, the same way your Spark streaming has got the built-in class functions that can start sending your data to the receivers through D streams, through multi-batch processing, through D streams and executors and all this funda. Now, this can also produce various type of outputs. Fair enough. Now, modifying the REPL CPU cores. This is one of the performance enhancement you need to understand. When you are working on Spark streaming, how is the virtual core process are linked with your tool, which is your Scala IDE, which is your terminal, which is your Eclipse, whatever it is. When running streaming applications, it is usually beneficial to use multiple CPU cores. It is beneficial to use multiple CPU cores. Your Spark REPL, read, evaluate, print, loop utilities can run programs on your local machine, which is called sandbox or a virtual machine or your local machine or whatever it is. Now, this Spark streaming applications should have number of cores equal to number of D streams being ingested plus a core for receiver itself. Very important, very important. Right, understand this. You can also add this point when you're talking to somebody about Spark streaming. The way you said, we use batch processing with the interval of 1 second. So it will be a time difference of 2 seconds the moment it received and moment it processed. Like that, you also can say we are doing a best practice that our application has a number of cores equal to number of D streams being ingested plus 1 core for receiver itself. Here, if you have 20 D streams, you should have 21 CPU cores available for best performance because one CPU core for your REPL. Okay, once again, I repeat, your Spark streaming application should have number of cores equal to number of D streams being ingested plus a core of receiver itself. Receiver itself means the way your source is starting a connection to receiver to send the data. So you have 20 D streams. So you have one more core, one more CPU core available for your REPL as well. This behavior can be changed but modifying the master environmental variable, which in the REPL can be done at the launch. Okay, I'll show you that. Now. Hope everybody is aware of it. Hope everybody is happy with this explanation. If you have any questions, please stop me then and there. Can we configure how many executors to use in Spark Streaming? We are going there. Good question. Very early. We are going there. Okay. If you see here, this is your you have Spark context. In that you have streaming context. You have a driver. Okay. Now, if you see here, PySpark master local 2. Why did I give 2 there? It says I want 2 drivers. I want a virtual CPU to be launched for each driver or for each thread, I can say. Now, launching streaming context. Streaming context is nothing but you first need to import streaming context API. For that one, you use from PySpark dot streaming import streaming context. Very simple. In PySpark, the code to perform this operation is from PySpark dot streaming import streaming context. Next, you need to create an instance for the streaming context. Guys, understand this one. I'm going to show you practically next 5 minutes. If you don't understand why I'm importing, if you don't understand why I gave SC,1, there's no point in you telling you worked on Spark Streaming real-time feeding data. You have to understand it. Very, very important. If you're feeling sleepy, just focus. Just 2 minutes, just focus. Let's understand that. Okay. Now, to launch streaming context, we have to import streaming context API. Fair enough. If you in PySpark to do that, it's very simple. From PySpark dot streaming import streaming context. Fair enough. Once this streaming context API is imported, okay, you have to create an instance. The reason why you create instance is you assign the variables to that instance. Now, when doing so, you supply the name of the Spark context in use. Perfect. As well as the time interval in seconds. Perfect. For the receiver to collect data for micro batch processing. This is where I have explained you in the earlier slide. We are doing the batch processing with a time interval of 2 seconds. Here, that SC,1 means you are telling this is the time your receiver to receive data every 1 second. Okay. Now, when using REPL, Spark context should be named as SC by default, which we already discussed. I have shown you very clearly. Spark is now used as SC, which is Spark context. Okay. For example, when creating an instance of streaming context named SSC in PySpark with a microbatch level, you need to see SSC equal to Spark context SC.1. Instead of doing SSC, you can also do Amarnath equal to Spark streaming context SC.com. You can also put ThoughtWorks equal to streaming context SC.1. That's up to you. It's just a variable you are assigning to your Spark context name or a streaming context name. Simple. Okay. Now, this we are done. This operation will return an error if streaming context API is not imported, which means if 1 minute, if this bit is not imported, your Spark streaming will not work at all. Okay, that's the core of your Spark streaming, because it is the one that will create your Spark streaming and your D streams for your source and receiver. Okay, now both the name of Spark streaming instance and the time interval can be modified to fit your purpose. I know that. Here is the example of creating streaming context instance of 10 seconds microbatch interval. SSC10 equal to streaming context SC,10. It is important to note that while multiple instances of streaming context can be defined, only single instance of Spark context run per JVM. This is very important. Again, we have jumped into performance optimizations, because as a developer, you need to understand when you write a code for your Spark streaming, when your data started processing from source to receiver, how your Hadoop cluster resources will be utilized for that one. Okay, that is the reason why, because you might be running you might be running a Spark streaming context from your machine. I might be testing something. Our colleague, somebody might be testing something. 10 people might be testing 10 different test cases of Spark streaming. But however, only a single instance of Spark context can run per JVM. Means Your process will initiate one JVM. My process will create one JVM. Our colleague process will create one JVM. That is the reason why we say only one single instance of Spark context can run per JVM. If you are running multiple Spark contexts by multiple users, those multiple users will create multiple JVMs. Under the JVM only, this will be invoked. This REPL communication to your cluster will be happening. Very clear. Now, what happens when they are running? When they are running, another instance will fail to launch. In fact, once the current instance has been stopped, it cannot be launched again the same JVM. Okay. Now you have a existing connection open with your, let me show you that here. What I mean to say is, now this one, okay, this will create one JVM. Okay. Now my JVM will end here. This JVM, because I have come across Spark, the JVM which killed cannot be reused anyway. But however, when you launch PySpark again, it will be creating a new JVM. That is what he's trying to explain here. Once running, another instance will fail to launch. In fact, once the current instance has been stopped, it cannot be launched again in the same JVM. Perfect. I've shown you that. Once again, thus, while REPL is a useful tool for learning and perhaps testing Spark streaming applications, in production it could be very problematic because every time a developer wants to test a slightly different application, it would require stopping and restarting REPL itself. Hope you got the practicality of this one, what I mean to say, and spending so much time on this one. Okay? Clear everyone? Any questions? Quick. Any questions? We have a lot more to discuss. I can answer your questions, but make sure we are understanding everything before going forward. Happy everyone? Okay, now perfect. Now streaming from HDFS directories and TCP sockets. Guys, is very simple. Don't worry about it. The way you have used RDD equal to sc.txt file your HDFS directory, same way to create a stream by monitoring HDFS directory and ingesting any new files that appear, choose a variable name for a D stream, then call text file stream function from streaming the context API and supply the full path to appropriate HDFS directory. It's very simple. ssc.text file stream. SSC is nothing but this one, wherein you create a streaming context, and when you created a streaming context, you have used a name for your streaming context as SSC. This SSC you are telling ssc.text file stream from HDFS directory. So if you write a code to pick up your data as per the streaming context, as per the timestamp the file has received, that will start processing the data. Now, if the HDFS directory exists on the cluster, the application attached to the only path need to provide is different. If it exists on separate cluster, then you have to append your HDFS name also. And other example what I wanted to cover here is how you will be working if you have a monitoring TCP socket source. That is very simple. Here you have text file stream, like that you have socket text stream. Here you need to give host name and your port number. Port number for your netcat will be 444444. I'll show you when we do the problem solved scenarios which contains Flume configurations also. Okay. Now in these both examples, the name of the streaming name of the streaming context instance had to be specified before calling the function. So this is the name of your streaming context instance. This is the name of your streaming context instance. Now this has to be called for sure before you start the functions. Now other applications would have tried to call this from default Spark context, and since these functions do not exist outside Spark streaming, an error would have returned. If you don't import the streaming context API and if you start working directly from Spark context, it will definitely fail. It will throw an error message. Okay, hope everybody is clear with that one. Let me move on. Now, how does the output console looks? To print the streaming output to console, terminal a window in Python, use prettyprint. Prettyprint is nothing but TP. ds variable name dot ppprint. In Scala, it is ds variable dot print. When printing output to console, we suggest setting the log level to Spark context to error in order to reduce the screen output, which means you have a logging mechanism called in 3 layers. One is info, 2 is warning, 3 is error. If you wanted to save your HDFS space, if you don't want all the trash and if you want only error messages, you can put sc.set log level equal to error. Otherwise, lot of informations besides what is being streamed will appear and cluster will up the screen. To do this, use a Spark context set log level equal to error. Okay. Hope you understood what is pprint and print. Pprint will be Python based and print will be Scala Java based. DS variable is nothing but dstreams variable name dot pprint, ds variable name dot print. And how to configure the logging will be sc dot set log level error. Okay, that's what it is. Now this is very important. Just quickly let's have a look. To save output as timestamp text file, use save as text file function. I have clearly showed you save as text file. We are very aware of it. Make sure application has right permissions to HDFS directory where it has to write the data. That's very important. Now, if you wanted to save as a timestamp, you have to use this one. This is nothing but your HDFS location, comma, prefix, and optional suffix. Prefix you will mention your time, and optional suffix, if you want, you can put it. The output will be generated on per dstreams basis, which is whatever you select as prefix prepending the rest of the file name, which will be timestamp. And now, in addition, you can choose to add an additional suffix to each file as well, which will appear at the end of the file. Prefixes and suffixes are useful, particularly if multiple data streams are being written to the same directory. Okay. It is also noteworthy that these outputs are not exclusive. You can choose to output to console and to HDFS without any issue. The whole fun of the slide is if you put timestamp here, it will be timestamp. You can also have optional suffix like underscore data from Flume, underscore data from Facebook, underscore data from Twitter, underscore data from Netcat, all these things. Okay, that is what I was trying to explain in here. One thing is very clear, your output will be generated on per day stream basis. On per day stream basis mean either 1 second interval, 2 second interval, 3 second interval. Once that is reached, with whatever name you give or you select as a prefix prepending the rest of the file name, means it will be timestamp. So your file comes with timestamp, and if you had some suffix, that suffix will be taken forward. Okay, fair enough. Let's go to second thing. Now, start and stopping streaming applications, very clear. With streaming applications, all operations must be defined before the streaming is started. Thus, interactively, benefit of REPL becomes lost. Once all transformations and outputs have been defined, to launch a streaming application, simply call Spark context instance and use the start function, which is nothing but ssc.start, ssc.stop. The application can be stopped in the same fashion when using stop function. For example, in REPL, the streaming application will stop if the terminal it is running is closed. Fair enough, we know that, we discussed already. Now, this is the basic example of simple streaming program while using REPL. Let me explain you and then I'll show you that. In this application, the PySpark REPL is called a master variable configured with 2 CPU cores to the local machine. This is the answer for your question, Mr. Suresh. That's sorted. Now, you are making a configuration that you are defining that you want 2 CPU cores for this specific process. Now, I told you very clearly you have to import a Spark Streaming API. In this Spark Streaming API, you have a batch interval of 5 seconds. And also, you are giving text to file stream system and you are giving your data as HDFS. Now, what happens is you also asking your HDFS to save as text file so that data will come and sit in somewhere based on the timestamp. After that, you are printing pprint, means you are using your pprint is Python. Okay, Python with Spark, and then you are using ssc5.start. Fairly very simple. 5 steps. First thing, your PySpark master, how many executors or how many CPU cores you want. importing Spark context, Spark streaming context. I'm sorry. Once you initiate Spark streaming context, you assign a variable for that one. That variable will be called throughout your function the way you wanted to use it. Are we using receivers in this example? Thondara. We'll go slowly. Wait. I'm just giving an example, simple string example. Receiver will be next thing. Don't worry. Okay. So your first question, what you asked, can we define the number of executors or no, that is fine. Absolutely fine. No worries at all. No worries at all. Absolutely fine. I like that. No worries. Okay. Now, this is a basic example. You did that. You understood the process. Anybody, any questions on this slide? Anybody, any one of you in this group have any questions? We have discussed very clearly. I'll repeat that. PySpark master local with 2 means you are launching 2 CPUs for your 2 executors for this process. You are setting your log4j configurations or logging configurations to show you only errors in the Spark. You are importing a Spark streaming with streaming context. You are assigning a variable for your API with streaming context sc, 5. I have shown you very clearly that one in here. I feel pity on people who missed the class today. Seriously. I pity them. This one. Your batch interval of 1 second. This is step 1. This is step 2. Okay. Now let me go back. Now we don't have stop here, madam. We don't have stop. Don't worry. We are not using stop here. Okay. Now once after that is done, you are giving you 1 minute. 1 minute. Now this one we have done. We have discussed it very clearly. This one is nothing but you are telling your SDFS input to go and use text file stream system because you are streaming data as a text file. Once that is received, you are saving it as text file in some other directory based on timestamp and you are asking to pprint. Now once you start this one, it will start from here, go here, go here, go here, go here, go here, go here and print your results. That's it. Fairly simple, straightforward. No confusions, no lafda. Okay. Now your transformations. The transformations what all you apply in Spark Core can also be applied in Spark Streaming. Your dstream transformations are similar in nature and scope to traditional RD transformations. In fact, many of the same functions of Spark Core also exist in Spark Streaming. These are the following functions: map function, flat map function, filter function, reparse function, union function, count function, reduce by key function, join function, and many more whatnot. You can use everything what you use in Spark Core. Now, this is the transformation using flat map. Very simple. If you remember my flat map process what I used earlier, that is the same process, but the only difference is this one, this one, this one, this one. After that, this one we all know, we have used it multiple times. Your lambda line dot split, it is using space as a separator, and using space you are separating your each of the line, and you have 4 lines, you have 4 inputs. These 4 inputs will be read as 4 blocks, 4 partitions. These 4 partitions it has to print SSC start. Simple. Okay, let me show that. I'll show you that. Bear with me. Any questions? Somebody asking something? There's no stop. Yeah, I told you that. Don't worry. That is done. Hope you are enjoying the session, guys. Where are we using our dstreams as RDD here? That's what I told you. This one, this from PySpark streaming import itself will do that work. Okay. If 1 minute. If you see here, this Spark streaming is composed of a receiver. This receiver is collecting the data in small amount called micro batches. and then makes them available for processing via a collection of specialized RDD called dstreams. The way you use sc.parallelize in Core Spark to convert your elements into RDD, you are not invoking anything here. When you import your Spark API from PySpark import Spark streaming context, that one itself will do that work for you. Hope your question is clear now. Okay, and this one is transformation using flat map. This one is combining these streams using union function. Okay, you guys may tend to confuse. Let me not confuse you here. This one you know, 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 this one you know. This one is combined input union input. This core Spark functionality I have already explained to you. But the only point is input one is a physical RDD there. Here it is a D stream here. How this D stream came is from this guy. Okay, that's all it is. This is done. Okay, now let me quickly go to next one. Creating key value pairs. This one also we have discussed. The only difference you have is this one, and after that you have a lambda line dot split, and again you are using map function. You are creating a key value pair. So each word will be a key and number of times it repeated will be a value. Later on it will turn into key comma list of values. Okay, this is where it is. That is what I was trying to highlight here. Let me move to next slide. Reduce by key. How you implement reduce by key, I have shown it very clearly here. And stateful versus stateless, very important. You need to understand this one, otherwise your D streams knowledge will confuse you. As previously discussed, by default D streams are discarded from memory when the next batch of data arrives. Once again I repeat, I told you very clearly when we discussed on Kafka, when you redefine or recreate a Kafka topic, the metadata that is stored in your Kafka topics, that when it started, when it transformed, will be deleted, but the core HDFS will not be deleted. Means when your Kafka topic is received, collected and transmitted, that is a metadata information stored on offset of each Kafka topic. Like that, your D streams are discarded from memory when next batch of data arrives. When the next batch of data arrives, it only stores the offset data of that batch till the time it is processed and the third one is in loop. Now, this behavior is fine, assuming all operations transformations are performed on a single RDD streams, single D streams, which are not dependent on previous data. But this mode of operation is referred to as working with stateless operation transformations. This means it is sometimes beneficial or necessary to perform transformations and gather output across overlapping slices or even across entire corrected data set. For that kind of things, what we do is you might want to compute a running average every 15 seconds using last 45 seconds worth of data. This is referred to as working with stateful operations and stateless operations. Very important. If you're talking to about somebody else, you tell our stream processing or our Spark streaming is based on the stateful operations, stateless operations. We have stateful data processing. We also have stateless processing. Uh, for example, our data comes every 15 seconds. However, sometimes it has to recompute the existing data based upon the last 45 seconds worth of data also. It is just but rechecking and doing a recompilation on the ascending data. This is the stateless and stateful and stateless operation. Okay, any questions on this one? Let me know. Checkpointing, very simple. Checkpointing is useful for the stateful streaming operations to maintain state in level of any system failure. Here, as discussed earlier, you don't want your earlier processed batch data to be discarded. You want it to be saved it. Okay, that is where your stateless and stateful operation comes into picture. This checkpointing is used till what time I can maintain that stateful information. To enable checkpointing, you just have to specify the Examples for stateful operations in real time. For example, the data that is reached into your SDFS, okay, and it has to wait for the next batch to arrive. In that case, you mentioned a checkpoint of 3 hours so that your now received data will wait for the next received data. It will compare and it will it will remove the stateful and stateless metadata after 3 hours because you have mentioned checkpoint 3 hours. In this 3 hours, the 10 seconds, 45 seconds recomputation will be done. Like that, your 1 hour, 2 hours work will be done, so you don't need the checkpoint again. Okay, this way, trying to write a stateful application without specifying a checkpoint directory will result in error once the application is launched. I repeat, trying to write a stateful application without specifying a checkpoint directory. Stateful applications always means your data that is arrived now so when you have the received data dependency with the oncoming data or streaming data or your D streams, that way you use stateful and non-stateful using a checkpointing. Checkpointing is also very important. Now let's talk about questions. Name the 2 new components added to Spark Core to create Spark Streaming. Name the 2 components added to Spark Core to create Spark Streaming. Okay, good, very good. If an application will ingest 3 streams of data, how many CPU cores it should be allocated? 3 plus 1, 4. Name the 3 basic streaming inputs that supported by both Python and Scala. Basic streamings will be SDFS and Netcat. Third one I don't remember. What 2 arguments does an instance Spark streaming context require? One is your import Spark streaming context and other one is defining a variable for your context. What is the additional prerequisite for the stateful operation? Checkpointing. What are the 2 parameters required to create a window? Window concept I have not created because that is out of scope for us. Let's go with the answers now. Name the 2 reasons, name the 2 components added to Spark Core. Receivers, D streams. Spark streaming context is also acceptable answer here. Fair enough. If an application will ingest 3 streams of data, how many CPU cores should be used? 4. Fair enough. Name the 3 basic streaming. SDFS. TCP socket is nothing but the same the Netcat. What 2 arguments does use? Spark context and micro batch interval. Fair enough. What additional prerequisites is required for your stateful operation? Checkpointing. What 2 parameters required for create a window? Window duration, correcting sliding interval. This is not covered because we don't need that one. Next one. Summary. Quick summary of what we discussed. Spark streaming is an extension of Spark Core that adds concept of SA streaming, data receiver, a specialized type of data called RD D streams. D streams are fault tolerant because it is replicated. Spark streaming utilizes a micro batch architecture. I know that. You know that. Spark streaming layers and Spark context on top of Spark Core context API. You know that. Many D stream transformations are similar to traditional RD transformations. You know that. Windows functions allows for operations across multiple time slices of the same D streams and are thus stateful. Stateful and stateless I have discussed. Windows I have not discussed. Windows function nothing but a function that is created so that you use the same operation across multiple slices of D streams. Okay. Now next one is Spark performance tuning, which we'll discuss little later. We don't want to discuss right now. That's all I have. Hope you all enjoyed. Now I'll tell you the reason why I ask you to read go to this video. Where is my Kafka? Let me show you that.
Okay, I wanted to make sure what's my topic name. Otherwise,
1 minute. Let me close this
possible
one.
issues of
1 minute, guys. I don't know why it is coming up like this.
things going wrong.
Okay, hold on. Let me come back here. Before that one also.
of consumer enough, and I'm asking you to let me see if the Zookeeper service is started. If I'll start my.
I wanted to show you the way I have imported a Spark context. That's where I'm coming from.
Once again, let's do any kind of data. Same thing. What we have seen earlier. Master.sh, perfect. Slider now. So how your classes work.
See here, guys, everyone, can you please kindly focus?
Okay, I wanted to make sure what.
Import arc.apache.spark.streaming Kafka utils. The reason why I have used this one is I am using Kafka here. You can use Flume also like that. And also guys, please understand something. SSE is arc.apache.spark streaming context equal to Spark streaming context. So SSE means Spark streaming context. I imported this. After I imported this, if you carefully observe, my Kafka streaming is using Kafka utils. It is creating a stream with using this one with the local host with 2181 port number and is using a consumer group and is creating a map operation in the test with 5 as the batch interval. Okay, this is the reason why I have requested everyone to kindly watch my Kafka Spark streaming a real-time scenario. I have explained more things in that one. If you have time today, kindly go and spend some time on it. We can discuss if you have any doubts. This is the reason why I stopped it here is this is the important which I want to focus. But if you understand it and if you go through the complete video, it will make things very easy for you.
Topic name.
Okay, that's all I have for today. It's 6:29. We finish it on time. Can I kindly ask everyone, do you have any further questions? Are you happy with Spark streaming? Do you understand the whole funda, what they mean in real-time streaming is? It took 4 hours for me to prepare the slides, but not 4 hours, 3.5 hours or something, editing, copying and doing it, but the class is finished in 1.5 hours. See the difference? Spark performance tuning very important, very important. More technically strong you are on Spark coding, the same level of expertise if you have on Spark performance tuning, you will be a master. You will be a master. You will be the most highly paid resource. Trust me. Okay, guys, 6:30. Quick thing before I go. Any questions? Please shout. Any questions today? Yeah, go ahead. Somebody's asking something.
So if we are using a text file in the example you have shown today, right?
Mm-hmm.
When Spark streaming is running, can we append data to the text file?
Come again. I didn't understand your question. Come again.
So let's say we have a text file in a node 2 cluster. We have 2 nodes, let's say, and we have file in node 2.
Mm-hmm.
And we have 2 terminals open, and on one terminal, Spark streaming is running.
Mm-hmm.
And on the other terminal, while the Spark streaming is running, can I append that text file to add more data?
You can do it.
Or is it locked?
You can do it. No problem at all. You can do it. No problem. See, what all you do, you can make any changes at your source. Okay. If you are making change to a text file that is already in HDFS, that is a problem. Okay. Because when you change the text file in HDFS, the timestamp changes. When the timestamp changes, your dstream tends to confuse with the micro batching because your micro batching feeds the data every 5 seconds to your destination. But this 5 seconds batching is now shattered because you have changed the timestamp of your destination, right? You need not have to confuse your destination text file which is in HDFS, but source you can change everything. Any change you can do on source.
Okay.
Clear?
Yeah.
Before I end this class, all the ladies, happy Women's Day. Have a good time, and we all wish you good luck and all the best for your future endeavors. God bless you all. Shailaja, Radhika, Swapna, Benazir. Okay guys, that's all I have. If you have anything, we can talk offline. Give me some time. You did not have to follow up with me on uploading the video. Once the video is converted, it will be shared with you. And once it is available, kindly please practice, please revise, please spend time and understanding things so that it will be easy for you in the long run. If you delay, you tend to forget things. That's only request, you know. Thank you. Have a good day. Enjoy your work. Yeah, I'll share the slides. Sure. Thanks.